In this lesson, our goal is for us to be able to say that I can write an equation of a line given the slope and a point on the line. And also, I can write an equation of a line that is parallel or perpendicular to the given line. So we have these two goals that we want to be able to understand. You guys have technically done goal 1 in Algebra 1. But it's been a few years since you've done that, so let's go ahead and just refresh about some key terms that you need to make sure you know. Slope. We just talked about slope the other day, or in another video. Reminder of what slope is. Slope is, we define it as the change in y over change in x. We have our equation, we say m, we call m our slope, equals to y2 minus y1 over x2 minus x1. You can think of this as the change in y over the change in x. You can also think of this as rise over run. Lots of ways to think of slope. You can also think of slope as the rate of change. Remember, average rate of change, it does not have to be linear, but slope does. Slope-intercept form. So slope-intercept form is now going to be taking us into an equation. Slope-intercept form you guys should recognize. And the nice thing about it is it gives us or tells us immediately what our slope is and what our y-intercept is. So we're going to know our slope and our y, specifically our y-intercept. This is equal, or this is, y is equal to mx plus b, where m is our slope and b is our y-intercept. Okay, so that's our equation for point slope form. And I'm going to show you how to write that equation given some points or the slope. Point slope form. This one is also a very useful format to know. The nice thing about this one is it gives you a point and it also gives you the slope. Hence why it's named point slope form. And we really were not that creative whenever we came up with these names. The names literally say what you know about it. The equation for point slope form is this. We have y minus by y1 or y2. Okay, it does not matter if you put 1 or 2 underneath. We just put 1 for simplicity's sake. Equals to m times x minus by x1. If you chose y2 and x2, that's fine. Just don't mix your 1s and 2s together. Have it either 1s or have it as 2. Okay. By the way, how we get point slope form comes directly from slope. So let me just quickly show you how this works. We have m equals to y2 minus y1 over x2 minus x1. If you wanted to write this a different way, if you wanted to write this without the fraction, we can get rid of the fraction by multiplying by the denominator. If you multiply by the denominator, you're going to multiply by x2 minus x1 on both sides. Well, this should look familiar. We have x2 minus x1 times m equals to y2 minus y1. And that is exactly point slope form. Just instead of saying y2 and x2, we just say x and y because we're not going to be substituting in the place of that. But that's basically how we get to the point slope form. The slope-intercept form is very, very similar. How we get to that, let's just go from this point slope form. And let's say we have the y-intercept. Let's say the y-intercept is 0, comma b, where b is an integer. Okay? If that is true, then we are going to replace the x1 and y1 with 0 and b. So we end up with replacing this would be x minus by 0 times m equals to y minus b. Okay, well, simplifying this, we end up with, let's pull this down just a little bit. This would be mx equals to y minus b. Add b to both sides, mx plus b equals y, or y equals mx plus b. That's how we get those equations. They come from slope, okay? So you don't have to know how to get to that necessarily. Main thing is you need to know that they came from slope, and that these always work. Okay, so that is what you really need to know. Let's look at an example. Write an equation in slope-intercept form for the line. So let's say we want to find some nice points. Since this is in slope-intercept form, we need to know the slope and we need to know what the intersect is. Specifically the y-intercept. Where does it cross the y-axis? Well, this one crosses the y-axis at 0, 3. Okay, so the y-intercept is at 0, 3. Now let's find the slope. We learned how to find slope in the other video. So let's go ahead and just find some other nice points on here. It looks like this could be a nice point right there. It looks like we could also have a nice point right here. So let's figure out the slope. Let's go from the blue dot to one of the pink dots. We go up by 2, over by 1, 2, 3, 4, 5. We could go down by 2, to the left by 1, 2, 3, 4, 5. As long as it's consistent, we know we chose wisely. And we know we chose the correct points. So slope is a positive, rise is 2, run is 5. By the way, if we were to put a little stick man on here and go from left to right, he's going upwards. So that's a positive slope. Remember, positive, we're going up the mountain. Negative, we're coming down the mountain from left to right. Always from left to right. So we have our y-intercept and we have our slope. So now let's just put in our equation. Remember, y equals to our slope times x plus b. Just substitute. So y equals to 2 over 5 x plus our y-intercept, which is 3. And that is our equation in slope-intercept form whenever you're given a graph. Let's do another one. Write an equation in slope-intercept form for the line. Well, let's first figure out our y-intercept. With this one, oh no. Y-intercept is somewhere between -5 and -6. That's not a nice point. So we don't really know the y-intercept. We could estimate it, but what if our estimation is wrong? So instead of doing that, let's go ahead and just find some nice points on this graph. Let's find any nice points that we possibly can. So let's look. We have a nice point right here at -4, -4, 0. We have a nice point right here at -1, -4. We have another nice point down here at 2, -8. We have another nice point over here at -7, 4. We don't have to find all the nice points. I'm just doing that to make sure our slope is consistent and make sure that we have the nice points. So let's just start from the one farthest left. We can go down 1, 2, 3, 4, over by 1, 2, 3, so down by 4, to the right by 3. If we continue with this, we go down by 4, to the right by 3, down by 4, to the right by 3. It's consistent, so we know we chose good points. So slope is equal to rise, which is -4, over run, which is +3. By the way, if we were to draw a stick man and look at the way he's going from left to right, he is going to be going down the mountain. So that makes sense that it's negative. Okay, so that's another way of checking if it's positive or negative. What we're going to end up doing with this one, in order to get into slope-intercept form, since we do not have the intersect, we're actually going to use the other format, then use our algebra skills to get back to slope-intercept form. So let's use point-slope form. We have y minus by y1 equals to m times x minus x1. Well, let's choose some points. Let's choose a point right at, let's say, let's do -4, 0. Let's choose a point -4, 0. That is a nice point right there. So if that is our point, then we now have that y minus by 0, right, because y1 in this case would be 0, x1, y1, equals to slope, which is -4/3, times x minus by negative 4. Minus a negative is a positive. So this would be y equals to, that's nice. It's just y now because the 0 added or subtracted onto that. Equals to negative 4 over 3 x plus, let me actually put that in parentheses, plus 4. We're going to do one more step. And now at this point, we are going to use our distributive property. So we need to distribute that negative 4 over 3. Distribute that negative 4 over 3. So y is equal to negative 4 over 3x minus by, okay, 4 times 4, which is 16. That's technically 4 over 1. 1 times 3 is 3. And that is in the slope-intercept form because it's y is equal to the mx plus b. So now we know instantly our y-intercept is 0, negative 16 over 3. And that would have been very hard to try to estimate. Let's look at an example that they do not give us the graph. What if they just give us 2 points? If we have 2 points and want to write an equation for this, what we are going to end up doing is we are going to end up just looking for the slope. We know how to find slope with 2 points. Let's just name some stuff. x1, y1, x2, y2. Remember, keep your 1's together, keep your 2's together. It does not matter which ones are 1's or which ones are 2's. We could name the first group x2, y2, and the second group x1, y1. It does not matter. Main thing is just make sure 1's stay together and 2's stay together. So slope, negative 14 minus by 7 over by 7 minus by 0, which would end up to be a negative 21 over 7, which gives us negative 3. That is slope. Looking at our points, they happen to already give us the y-intercept. Anytime you see 0 in the x place, that's a y-intercept. So we already know the y-intercept, so now we just have to substitute. Y is equal to slope, which is negative 3. X, our y-intercept is 7, so plus 7. And that is slope-intercept form. Looking at another example, write an equation in slope-intercept form given m is equal to 1 over 2, and the line passes through the point 4, 9. So they give us the slope. That's nice. However, they do not give us the y-intercept. We want to put this into our slope-intercept form. So remember, we need the y-intercept in order to do that. But we do have another format that we can put it in and slowly transition it over using our algebra skills. So we use our point slope form, which is y minus by y1 equals to m times x minus by x1. Slope is 1 over 2. We have the point. Let's call this x1, y1. So y minus by 9 equals to 1 over 2 times x minus by 4. That's point slope form. So if I asked you guys to write it in point slope form, that would be the answer. But because once it's in slope-intercept form, we're going to go ahead and solve for the value of y. Remember, we need it in y equals mx plus b. So let's go ahead and do some simplifying. Y minus by 9 equals to 1 over 2 minus by half of 4 is 2. Get the y by itself, so let's add 9. So y is equal to 1 over 2x. Don't forget your x's, otherwise we could end up in some interesting spots, plus 7. And that is now in our slope-intersect form. Slope is 1 over 2. Intersect just happens to be 7 in this case. Let's do one more of these, then we're going to get into the parallel and perpendicular stuff. Write an equation in slope-intersect form given the line passes through this. They don't give us the slope, and they also do not give us our y-intercept. So that means we have a little bit more work ahead of ourselves. So let's find the slope. M is equal to, let's do negative 7 minus by negative 9 over by 2 minus by 4. Remember, y2 minus y1 over x2 minus x1. If this is x1, y1, x2, y2. This would be equal to negative 7 plus 9 over by negative 2, which gives us a 2 over negative 2, which gives us a slope of negative 1. So that's our slope right there. What we can do, we can plug any of these points in. We will end up with the same exact slope-intersect form no matter which point we decide to use. Whether we use the 4, -9 or the 2, -7. It will give us the same exact slope-intersect form. Does not matter which point you choose. I am going to choose, let's do the 2, -7. So y minus by -7 equals to -1 times x minus by 2. Right? We're using point slope form because we do not know the intercept. If we knew the intercept, we could just plug it right in. But because we do not know the intersect, we cannot just plug it right in. Okay, so we had to take a few more steps with that. We want to distribute. This would be a y minus a negative is a plus 7 equals to -x plus 2, because -1 times -2 is positive 2. Subtract by 7 on both sides. Subtract by 7 on both sides. So we have y is equal to -x minus by 5. And that is in our slope-intersect form because it's solved for y. Remember, y is equal to mx plus b. That is the goal for that. Now let's talk a little bit about parallel versus perpendicular. You guys hopefully have all taken geometry. I'm pretty sure you guys have. So we're going to see what parallel means and what perpendicular means in terms of algebra. You guys all know that parallel lines, they never cross, at least in our Euclidean geometry, in the regular geometry that we do in high school. So parallel lines, they never cross. What's special about them, as you may have learned in geometry, is that their slopes are the same. Okay? So slopes are the same. Example of this, we could have, let's say y equals to -2x plus 7 and y equals to -2x minus by 5. These are parallel because they have the same exact slope, which is -2 in that case. Okay, that's how you know it's parallel. Same slope. Perpendicular. How do we know if it's perpendicular? We're going to take the two slopes. Let's call one of the slopes a over b. Okay, let's have it as a ratio of two integers. Let's multiply it by the perpendicular slope. Perpendicular slope is always the opposite of the reciprocal. Okay, perpendicular slope is always opposite of the reciprocal. If it is perpendicular, then it will always equal -1 whenever you multiply the two slopes together. Okay, if you take your two equations, multiply them together, if it equals -1, it's perpendicular. If it doesn't, we might have did something wrong. By the way, perpendicular lines, whenever they cross, they form 90-degree angles. So that's what you would have learned in geometry. Let me give you an example of this. Let's say we have y equals to 3 over 4 x plus 7. A perpendicular line to this could be y is equal to -4 over 3, the opposite of the reciprocal, x, let's say, minus by 10. These are perpendicular because the slopes are opposites of the reciprocal. That's how you know the difference between the two. So now let's actually use it in practicality with some graphing. So write an equation, slope-intersect form. I like the slope-intersect form, so we're going to keep on doing that. For the line that passes through 4, 9 and is perpendicular to the line with the equation y is equal to -2 over 3x minus by 7. Well, we are looking for a perpendicular line. Because we're looking for perpendicular, let's pay attention to the slope. Even if we were looking for parallel lines, we would pay attention to the slope. The slope of this one is -2 over 3. Perpendicular, opposite of the reciprocal. Opposite of the reciprocal. So the new slope, opposite would now be positive. Reciprocal would be 3 over 2. Right? If you take -2 over 3 times 3 over 2, that's going to give you -1. So that's our slope. We also know that it's going to pass through a certain point. 4, comma, negative 9. Well, that's not our y-intercept. So now let's put it into point-slope form and solve for the slope-intersect form. So same thing we've been doing. Y minus negative 9 equals to 3 over 2 times x minus by 4. Let's simplify a few things. Minus negative is positive. Distribute. So y plus 9 equals to 3 over 2. X minus by, okay, 2 and 4 have 2 in common. You're left with 2. 3 times 2 is 6, so minus by 6. And at this point, all we have to do is just get the y by itself. Opposite of addition is subtraction, so we minus by 9, minus by 9. So y equals to 3 over 2 x minus by 15, because if they're both negative, you're adding them together, it's going to go farther negative. So this is a line that is perpendicular that also passes through the point 4, comma, negative 9.